welcome back. So in this video, we will see the questions of Coulomb's law, and these are very easy, simple questions in which we will directly use the formulas. Okay. So let us see the first question here. What it is? It says that 2 point charges carrying charge 3 into 10 to the power 9 and minus 5 into 10 to the power 9 Coulomb. These units are Coulomb. Okay. Are 2 meters apart. Determine the magnitude of force between them. So you are having two charges. One charge is Q1, which is equals to how much? 3 into 10 to the power 9 Coulomb, right? Yeah, and the other charge is Q2 is equals to minus 5 into 10 to the power minus 9 Coulomb. And the distance between them is R is equals to 2 meters. So all the units first you need to check. So all are having their SI units. Okay. So we know the formula of Coulomb, right? What Coulomb's law says us. F, electrostatic force of attraction or repulsion. So here if you see, this is a positive charge, right? And this is a negative charge. So positive and negative charge will have what? Force of attraction. So the electrostatic force of attraction will be how much? K Q1 Q2 by R square, right? And the value of K was what? 9 into 10 to the power 9, right? And Q1 is equals to 3 into 10 to the power 9. Q2's value is minus 5, which you can directly write only the magnitude. Okay, no sign. Into 10 to the power minus 9, right? And it's divided by how much? R square, which is 2 square. Okay, so from here you can directly write 9 3s is 27 into with 5. And here you can write what? Plus 9 minus 9 will cancel out and just 10 to the power 9, right? Divided by 4. Now, when you will do this calculation, you will get 3.37 into 10 to the power 9. You can just calculate and see. And finally, you can write it as 10 to the power 8. And this one, you can make it as 33.7, right? Newton. So this is the answer. Clear? Sometimes you might be asked that what is the force? Either it's attraction or repulsion. Repulsion, then you can just see if it's opposite charges, then it will attract. If it's like charges, then it will repel. Clear? Now let us see the next question. So here it is said a positive charge of 6 into 10 to the power minus 6 Coulomb is 0.040. How much? 0.040 meter from the second positive charge of 4 into 10 to the power minus 6. Calculate the force between the charges. So here you are having a charge Q1. Okay, this is a charge Q1. And the value of this charge is how much? 6 into 10 to the power minus 6. And another charge, which one you're having? Q2. And the value of the second positive charge is how much? 4 into 10 to the power minus 6 Coulomb. Clear? And it is said the separation, okay, the distance. A positive charge of this much Coulomb is this from there is 0.40 away. It will be away, okay? So the separation between these two charges is how much? The distance is how much? This distance is 0.040 meter. So this is meter, this is Coulomb and Coulomb. First you need to check the units. So all are having the SI units. So directly you will use the Coulomb's formula, which is F is equals to what? K Q1 Q2 by R square, right? So here when you write F is equals to the value of K is what? 9 into 10 to the power 9. Q1 is 6 into 10 to the power minus 6, right? And Q2 is equals to what? Q1 is 6 into 10 to the power minus 6. This is 4 into 10 to the power minus 6 divided by R square. That is how much? 0.040 square. All right, this is what you're having. Clear? So F is equals to, so when you will do, so this numerator, when you will calculate the entire calculation, this is minus 12, right? This will give you minus 12. Then when you will do, you will get minus 3. You can see the calculation in the numerator, what you will get? 0.21576. And denominator, you can write it as by 1000, all those things. You can do it on your own, okay? This you will give you in the denominator 1.6, okay? 1.6 into 10 to the power minus 3. Okay, this is how you can calculate. I think this is simple. You can do the calculation on your own. Clear? So when you will calculate this, you will get the electrostatic force of, this is repulsion. Both are positive charge, okay? You will get it equals to 134.85 Newton. Okay? So you will get this to be the answer. And if you ask that what type of force is there, then you will say force of repulsion, right? they will have repulsive force. In the last question, you were having the attractive force. In this question, you will have the repulsive force. Clear? So these are direct questions. The only thing that you need to remember is that in this formula, you are dealing only with the magnitude of charges, right? You don't need to mention the direction. For the direction, you will go in the vector form. And what you need to see is whether it's the attractive force or the repulsive force. Clear? And you need to check out the units. Okay, all the units should be same. If it's SI, then SI. If it's CGS, then CGS. This is the most important thing that you need to check. So that's all in this video. Thank you so much. Have a good day.